Lovely students. How are you? I hope you are quite well, happy, healthy, and your study is going very smoothly. Today, this is lecture number 1. We are going to start the method of preparations of aldehyde and ketones. And the first method of preparations will be from oxidation of alcohol and alkene and alkynes. So, students, let's start. Once you understand, please like, share, and subscribe the channels. Students, see here, we have to prepare aldehydes or ketones. Okay, both are the carbonyl compounds. How to prepare strength from alcohol? From alcohol, this is the RCH2OH. If we have to prepare aldehyde, that is the RCHO. We have to use here mild oxidizing agent. Okay, or second, if you have a 2-degree alcohol strength ROH or less, then you can take here mild oxidizing agent and you will get that ketone. It means through mild oxidizing agents, if you have a 2-degree alcohol, that will convert into the ketone. If you have a 1-degree alcohol, that will convert into the aldehydes through the mild oxidizing agents. But students, if we take the strong oxidizing agent, then 1-degree alcohol will convert acid. Okay, so we are going to understand which is the strong oxidizing agent and which is the mild oxidizing agents. Let's start, students, oxidations. So what I am telling you, the oxidation of alcohol is done by strong oxidizing agent and second weak, or you can say that mild oxidizing agent. OA means oxidizing agents. Okay, so see that earlier I said that through strong oxidizing agents 1-degree alcohol will be converted into the acid. So what would be the, and 2-degree alcohol will be converted into ketone. So 1-degree will be oxidized into the acid and 2-degree will be oxidized into the ketone through the strong oxidizing agents. Okay, students, through weak or mild oxidizing agents 1-degree will be converted into aldehydes, 2-degree will be converted into ketone, except catalytic dehydrogenation, because catalytic dehydrogenation is also considered as a mild oxidizing agent. So except catalytic dehydrogenations, 3-degree alcohol will be not oxidized by mild oxidizing agents. Understood what I am telling you? Again, I repeat that through mild oxidizing agent, 3-degree alcohol will not be oxidized except catalytic dehydrogenation. Okay, now we will understand here. So first I write here, students, what would be the strong oxidizing agents? You can say that the KMNO4 H plus, K2 Cr27 H plus, CrO3 H2O. Still, these are strong oxidizing agent, which 1-degree alcohol will convert acid, 2-degree alcohol convert into the ketone. Correct? So these are the reagent strengths which will convert 1-degree alcohol into acid and 2-degree alcohol into ketone. Okay. Now we talk about the mild. Strength mild oxidizing agents. See that the mild oxidizing agents, I write here one, that is the very popular name is PCC, pyridinium chlorochromate. What? Pyridinium chlorochromate. So pyridinium chlorochromate is that first we draw the structure of pyridine, chromate, CrO3, HCl. This is the formula of PCC. Okay. First I write all the mild oxidizing agent here. Second, I am going to write here that is the Jones reagents. Okay, so Jones reagents. So Jones reagent is a what? CrO3 H2SO4. This is the Jones reagent. Third strength, Collins reagents. Collins reagent. These are the mild oxidizing agents. So Collins reagent is the pyridine. First I write the pyridine and CrO3 and CH2Cl2. Right? This is the Collins reagent. And fourth I write here, that is the PDC, pyridinium dichromate. Pyridinium chromate, you can say. So pyridinium chromate, pyridinium chromate. Here is the what? That is the, here is the first I write the dipyridine chromate. You can say here Cr double bond O, and double bond O, and one more pyridine. Okay. So dipyridine, PDC means dipyridine chromate. Correct. And fifth I write here Serret's reagent. What? Serret's reagent. Serret's reagent is what? That is the pyridine and CrO3 HCl CH2 Cl2. These are the Serret's reagent, and these are the mild oxidizing agents. Okay. Students, see here one more mild oxidizing agent. So all these reagents which I have written here, these reagent strengths convert 1 degree alcohol into aldehyde and 2 degree alcohol into ketone. Okay. Now we talk about we have catalytic hydrogenation. See here, what I'm telling you, that we have a reagent is catalytic dehydrogenation. This is also considered as a mild oxidizing agent, but it convert that 1 degree alcohol. See here, it convert 1 degree alcohol, copper, heat. So 2 hydrogen we lost, and which will convert here the CH3, CH2, CHO. Okay. So 1 degree alcohol convert into the aldehyde. Next, 2 degree alcohol. Here is the CH3, copper, and heat will take 2H will loss, and then will form the CH3 C double bond O CH3 ketone. So both the process are dehydrogenation. These two processes are dehydrogenation process. Now, if you take the 3 degree alcohol CH3C and CH3OH CH3 strengths, and the copper heat, again water is lost. Here is the form CH3 C CH3 double bond CH2. So this process is called dehydrations. Okay, that is reduced product. It is called reduced product. Correct. This is the reduced product. So have you seen that the catalytic hydrogenation, it is also considered as a mild oxidizing agent, but it converts 3 degree alcohol into the alkenes. Okay. Still one more mild oxidizing agent is MnO2. This is called selective oxidizing agents. What would be the MnO2 is selective oxidizing agent. Why it is called selective oxidizing agents? Because it oxidized allylic and benzylic alcohols into aldehydes, both. For example, you can see here CH3 CH double bond CH CH2OH. This is the allylic compounds. So when you take the MnO2, that the alcohol will convert into the aldehydes. What? That will convert into the aldehyde group. Okay. One more, see here. If you have benzylic compound CH2OH and you have taken that MnO2, that will convert into the aldehydes. Okay. So this is the selective oxidizing agents. Student, I give you the one example, and then you see that CH3 CH double bond CH OH and CH2OH I have taken. Okay. Now you tell me, if I take here the K2CR2O7H plus, what will happen? Student, when we'll take the K2Cr27H plus, then that will be the double bond will be broken here, double bond will be cleaved here. So this part will convert into the acid part, okay, and here the 2-degree alcohol will convert into the acid. This part is the acidic part, here is acid, here is also acid. This point is also acid. So second, C double bond O, OH, right, and here will form the, here this whole the group, that will what happen, C double bond O, CH2, and here is the 1-degree alcohol. So C double bond O, CH2, C double bond O, CH2, and CHO, okay, correct, 1-degree alcohol, sorry, COOH, I write here properly. So that is the 1-degree alcohols, na? It is 1-degree alcohol. So what happened? COOH. So this part, 1-degree alcohol form the acid, 2-degree alcohol form the ketonic group, and this part will form the acid, and this part is also form the acid. I hope you understood. Again, same compound we have taken here. I assume that is the A, okay? So same compound I take here, students, A. So when the A react with the PCC, can you tell me what will happen? Still nothing will happen with this double bond. Means double bond will remains the same way. So what will happen? The CH3, CH double bond CH, okay. Here will form the alcohol will form the 2-degree alcohols, ketones, and then 1-degree alcohol here, you can see here, 1-degree alcohol will form the aldehydes through the PCC. Okay. A, we have a CrO3. As you know, CrO3 is also, that is the CrO3 aqueous acetone. Okay. Not, I have not taken here water. So I have taken the CrO3 in the aqueous acetone. It means, so what will happen CrO3 when we take the aqueous acetone? You know, so CrO3 is the strong oxidizing agent. But what will happen when we take the CrO3 aqueous acetone? See here, that will double bond will not be cleaved here. Double bond will remains the same position. CH3 CH double bond CH. Okay. So here will form the 2-degree alcohol will form the ketonic group. Okay, and 1-degree alcohol will be acid form. This is the 1-degree alcohol which form the acid form. Okay. So and when we take the A and MnO2, what do you think? What will happen, students? This is the allylic positions. Am I right or not? This is the allylic positions. So these allylic positions will be converted into the ketone. Okay, and here will remain same because it is not allylic position. This is not allylic positions. So only this part, what I am telling you, give the attention here, student. Only this part will be oxidized because it is allylic positions, double bond, single bond, OH. It is allylic positions. Here is the 1-degree alcohol. So 1-degree alcohol will not be disturbed by the MnO2. So simply what will happen? The compound will form CH3, CH, double bond CH, C double bond O. Okay, CH2, CH2, OH will form. So I hope you understood the oxidation of alcohols, how to classify and which reagent will be suitable for the 1-degree alcohol or 2-degree alcohol or allylic alcohol. So I hope you understood it. Now we go to the second method of preparation. That is the oxidation of alkenes. What is the part? It is the oxidation of alkene. So oxidation of alkene here, how to see that? Oxidation, second part is that oxidation of alkenes or alkynes. Okay. See, students, oxidation of alkenes we will do here by 3 ways. One is ozonolysis. Second, we will do here oxo process. And third, we will do here Walker process. So, NEET students, you can ignore these 2 topics. Okay. And rest JEE students, we have to do all the things. Now we talk about ozonolysis. Student, ozonolysis, we have 2 parts. One is that oxidative ozonolysis. One is that oxidative ozonolysis, and second is that reductive ozonolysis. First, what I am telling you, at first is the oxidative ozonolysis, and second is that reductive ozonolysis. Okay, see here, students. Oxidative ozonolysis means what? We have to take here O3 and H2O2, hydrogen peroxide, not a zinc. When we'll take here O3, zinc and water, that is the reductive ozonolysis. Okay. So see what the difference between the oxidative and reductive ozonolysis. First we talk about students oxidative ozonolysis. See, through oxidative ozonolysis, suppose you have a group like CH2 double bond CH2. Okay, I'm not going to into the detail of the mechanism that how to form. See here, simply you take that O3 and H2O2, what will happen? That will clipped, the bond will be clipped here, and what will form? That form the first it form the acid and then will form the carbon dioxide. So directly I write the carbon dioxide. Okay, what happened? First it formed the acid. Again, this is the H2O2. Will do that, convert into the CO2. So directly I have written here. Now we talk about, suppose you have R CH double bond CHR. Okay. So when we take the O2 H2O2, what will happen? The bond will be cleaved here, and that will form the acid, right? But students, see that if we have RCR double bond CRR, exactly what will happen? Just you guess here that the ketone will form. H2O2 we have taken, RC double bond OR form, ketone will form. Okay, so exactly same thing will happen with the alkyne. Suppose we have alkyne, students, I write here. Suppose we have alkyne and we have taken that O3 and H2O2, exactly CO2 will form. First acid will form and then CO2 will form. Okay. Similarly, if you have a here is that, suppose we have like that alkyne is there. Okay. So I write here alkyne RC triple bond Cr, exactly O3 and H2O2 you have taken, that will form the acid. So exactly whatever what happened with the alkene, same thing will happen the alkyne also. Okay, so CO2 form and acid form just like a alkenes. Now we talk about reductive ozonolysis. Student, reductive ozonolysis we have done in the hydrocarbon chapter. Okay, so exactly I know a few things you know about the reductive ozonolysis. See here. So reductive ozonolysis, reductive ozonolysis. What will happen with the reductive ozonolysis? Student, reductive ozonolysis. Suppose we have taken the CH2 double bond CH2 and O3, zinc and water. So what happened? You remember that H, C, H, O, C, H, H. So we have done it just like that, and then zinc, water. What happened? That will directly convert formaldehyde. So every step I am not going to do like that. Simply you understand that things we have done. Okay. Now similarly, if you have RCH double bond CHR, what happened? That will convert into the aldehydes. Okay. Same thing. If you have a CR double bond CRR and O3 Zn H2 will what will happen? That will form the ketone. But here is a twist. What the twist is? Suppose you have alkyne. What? Alkyne means R C triple bond Cr. Then O3 Zn water. Do you think same like oxidative like that product will form? No. Here that it will form diketones. Here is that it will form the diketone esters. So this is called diketones will form. Okay. Suppose you are taking here HC triple bond CH. What do you think? What will happen? One part will be C double bond O and second part will be aldehyde. That is called keto aldehyde. It is the product will not be same like the oxidative ozonolysis. No. Instead of O3 and H2O, you can take the PB water also. You can also take here CH3 or 2S. You can also take here CHCl2. So exactly these substances work like ZnH2O O3. The same thing will work like ZnH2O. Just like ZnH2O, these substances will work. Of course, you have to take the O3, but instead of ZnH2, you can take these substances too, and you will get the same product just like ZnH2. Okay, so Now we talk about the one oxidations we have done the alkenes or alkyne through the ozonolysis. Now we talk about the oxo process. See students, oxo process is a what? Oxo process is also called hydroformylation. What? Hydroformylation. Or you can say that carbonylations. Carbonylations. Either you can say that hydroformylation or carbonylations. What happened? Actually, students, oxo process will follow anti-Marconi-Cox rule. Anti-Marc rule. Okay. And what would be the reagents? Reagent is here. CO. Here is CO all 4. This is the reagent that is called cobalt, or you can say like that COH. It is CO4. That means cobalt. You can say that cobalt hydride. So cobalt hydride you can take here. See what happened. In the brief, I tell you that olefin means alkene, will combine with the water gas. Water gas means CO plus H2, CO plus H2, not H2, CO plus H2. I write here CO plus H2. This is called water gas. So when we'll take the olefins plus CO plus H2 in the cobalt and cobalt COH, CO all 4 or CO all 4. Okay. So either you can take this reagent or this reagent. You will get that aldehydes. What you will get that? Aldehyde you will get. Now we understand the 2 examples. First I write here is one example. CH2 double bond CH2. And you have taken that CO plus H2. Okay. And then the cobalt and COH, CO all 4 you have taken. That or CO all 4 2 you have taken. Then what happens? Student, it will form the CH3 CH2 CHO. You will get that CH3 CH2 CHO. Okay. Now I give the one more example. Suppose you have here is that compound like that CH3. Okay. And CH3, right? Double bond CH2. And student, you have taken that 2CO plus 2H2. Then what will happen? Just to imagine what will happen. Then in that case, of course, you have taken this reagent streams. What do you think? What will happen? First, it will form the CH3 C and CH3, right? Here is the CH2 CHO. It is a major product because it follow the what? It follow the anti-Marconi-Cox rule. Okay. And second will be the minor. And what will happen? The CH3 CHO and CH3, you will get that. This is the minor product. So I hope you understood the oxo process. Now we talk about student Walker process. So what happened through Walker process? There is a Walker process. Student, Walker process is exactly what? Walker process is directly convert alkene directly oxidized. What happened? Alkene directly oxidized to either the aldehydes or ketones. Okay. So how it will happen? I am telling you that the terminal alkenes, about the terminal. So actually, student, what happened? Non-terminal will convert always ketone, and terminal always give the aldehyde group. Terminal, see here. So what I'm telling you, see that the CH2 double bond CH2. This is the compound like that. And so actually first you understand what would be the reagents here. What reagents we will use here. That's a very, very important. Okay. So terminal alkenes we will take here. See student, we will take here a solution of big amount of CuCl2 in the presence of either the air or O2. Means we have the reagent like CH2 double bond CH2 and H2O you have taken plus PdCl2 and in the presence of CuCl2 air or O2. So what will happen, students? That will form the CH3CHO and plus Pd. So 2 hydrogen that will form the 2HCl. Okay. Similarly, one more example I take here. R CH double bond CH2. Okay. And you have taken the H2O plus PdCl2 in the presence of CuCl2 air or O2. Then what happened? That will form the R C double bond OCH3. You will get that, and plus what happened? Pd plus 2HCl you will get. Okay. So have you observed in this compound one thing? The PdCl2 convert into the Pd, that is reduced form. Correct? Done that. So, or you can say that CuCl2 also reduced into Cu form. So either the PtCl2 reduced form into the Pd, that is the reduced form. You get that in the product. You can see here Pd, and similarly CuCl2 also get the Cu as a reduced form. Both are the reduced form. Okay. Students, so ultimately what I am telling you, the one thing in the ozonolysis of alkenes, you can keep here one thing in the ozonolysis of alkenes. See here. What? The unbranched always give the aldehyde. Okay. And branch will give the ketones. Okay. These things you will get that. So students, I hope you understood all these topics. Take care. Thank you so much. Have a nice day.